Let's talk a little about the domains of functions. Before I do, and I'm not going to emphasize this in every video, I think it would get very old very fast, but I do want to emphasize that these videos are not a replacement for reading the textbook. These videos are when I have things that I think are especially important that I want to emphasize, or for when I have something to say that isn't in the textbook or that the textbook sort of glosses over. So, like the textbook, lots of stuff about relations, that's all fine. I don't have anything extra to tell you about relations. You can just read that material and watch the videos that the publisher provides. I do have a little to say about domain, specifically as it relates to calculus. So the domain is the set of valid inputs of a function. And the word valid is doing some work here because there are multiple ways a number could fail to be in the domain of a function. So an input might just break an equation. And if the input breaks the equation of the function, then the input shouldn't be in the domain of the function. Like maybe we have an average cost function. So C with a bar above it is going to be the average cost. And I'm not saying that this numerator is very realistic. But the denominator of an average function cost function is going to look like this. So what this function is doing, it's taking as an input x the number of objects. Let's say the number of objects manufactured in a factory. And the output, this C with a bar above it, is going to be the average cost per unit. So, when we just see these descriptions of the input and the output, it seems like maybe you could set X, or maybe it doesn't seem that. Maybe it's intuitively obvious that asking about the average cost per unit is incoherent if there are no units. But I mean, physically speaking, you can certainly have a factory that's shut down and doesn't manufacture anything. Physically, it's certainly possible to manufacture 0 units. It's not in the domain of this function, though, because it breaks it. If we try to let x equal 0, 0 minus 0 plus 0 plus 1, 1 divided by 0 is undefined. It's a division by 0 error. But what about a number could fail to be in the domain in a second way? An input might make no real world sense. Like, what if I set x to -2 here? Setting x to -2 does not break this equation. Again, I know the calculator is fuzzy and unpleasant to look at, but you see we're not getting an error message. We're getting 44.5, if you can read that. But what's it mean? I mean, can we manufacture -2 units? We surely cannot. So -2 is not in the domain. But here's what's interesting, or at least here's something we should quietly keep in the back of our minds. Calculus as presented in an applied calculus textbook, or indeed in a regular textbook. Let me try that again. I promise I can spell textbook. Calculus, as it's presented in these classes and at this level, really needs the domain to be an interval. So very often a closed interval, but that's not so important. But we do textbooks on like textbooks. I can spell, not so sure I can speak. But you know, we might do calculus on a function defined on the interval from 2 to 7. Or we might do calculus on the non-negative numbers. And this are often at odds with one another. So suppose we have a revenue function. So x is our input, and let's say x is the number of units of something that you successfully sell. And y is the revenue you would generate from that sale. Well, maybe we have this relationship. Very, very simple model. Here, every object we sell generates $5 in revenue for us. But I mean, when you talk about selling units, I mean, whatever these are, widgets, would be the classic made-up business word. We can usually only sell integer units of something. So, I mean, in the real world, the domain of this function is going to be that we could sell 0 units or 1 unit or 2 units or 3 units, etc. So the domain of this function is, gosh, I hope you've been able to hear the words I've been saying. The domain of this function is the positive integers, and maybe there's a maximum value too. Like you only have 1,000 units in stock, so you can't sell more than that. So in these situations, we often idealize. In order to be able to do calculus, so in order to have an interval, we pretend the domain includes numbers that it doesn't. So we act as if the domain is an interval, even if it really isn't. So that's very common. So if you're doing, a homework problem or working through an example and, you're thinking that the domain the textbook is giving doesn't quite seem right, very often it isn't, because the textbook is intentionally sort of waving its hands a bit so that we can do calculus with this function, even though, properly speaking, it's not defined on an interval.